Here's an explosion that you can make. Want to know how? Then keep watching.
Hello, young neighbors. Welcome to Junior Science. Today, we're going to talk about automobiles. We're going to open them up, look inside, and find out what makes them go. Now, the inside of an automobile looks very complicated, but actually, you can show yourself how an automobile works by doing a few simple scientific experiments. Now, we all know that an automobile runs on gasoline. In the automobile, the gasoline is mixed with air and exploded. Here's an experiment which will show you that a mixture of gasoline and air is explosive. Let's fill a clay pipe with absorbent cotton. Now let's put gasoline until the cotton becomes well soaked. Then let's dip the pipe in some soap suds and blow a bubble. Now, watch what happens when we touch the soap bubble with a lighted candle. So we know that a mixture of gasoline and air explodes when a flame touches it. In an automobile, the gasoline is mixed with air in this part, which is called the carburetor. And here's an experiment you can do to show yourself how the carburetor does it. Cut a soda straw in half. Now stand one half in a glass of water. Hold the end of the other straw next to it. Now if you blow hard across the top of the standing straw, the water will climb up the straw, mix with air, and shoot out in a fine spray. Why does the water go up when you blow? Because moving air has less pressure than still air. When you blow across the straw, ordinary air pressure on the water in the glass pushes it up toward the tip of the straw, where the air has less pressure because you are blowing across it. And that's how gasoline is mixed with air in the carburetor of an automobile. In the carburetor, air must pass through this narrow tube on its way to the engine. This tight squeeze makes the air speed up, and it pulls drops of gasoline from this tank. And now, let's see what happens in the engine of an automobile. An automobile engine is made up of 6 or 8 round, hollow tubes called cylinders. This is what a cylinder looks like. And this is a piston, which moves up and down inside. Now, in each cylinder, there are 4 movements, or strokes, and these movements are repeated over and over. The first stroke is called intake. In this stroke, the intake valve opens, the piston moves down, and a mixture of gasoline and air is sucked into the cylinder. Now, the mixture of gasoline and air can be exploded just the way it is, but we get more power out of it if we compress it before we explode it. So the second stroke in each cylinder is compression. And now we're ready for the really important stroke of our gas engine, the power stroke. When the piston is ready for the power stroke, a spark jumps across the spark plug and explodes the gasoline and air mixture. The explosion pushes the piston down with tremendous force. Now, there is an exciting experiment that you can do right in your own home to show how this power stroke works. But you must do this experiment exactly as we're going to do it now, because otherwise it can be very dangerous. Instead of the cylinder, we use a coffee can with a small hole punched near the bottom. In place of the piston, we use the cover of the can. and in place of the spark plug, a match. We fill a medicine dropper with gasoline and cover the gasoline bottle and put it at least 20 feet away from where we're doing the experiment, or better still, in another room. Now we measure 5 drops of gasoline into the can. No more, because more is very dangerous. We cover the can and put a candle under it to vaporize the gasoline. And now for the power stroke. Are you ready? Here we go. We attach a match to a long pencil with a rubber band. Light the match, and holding the far end of the pencil, put the match in the hole. The match acts as a spark plug and explodes the mixture of gasoline and air. Well, that's what happens over and over again in every automobile at the power stroke. The gasoline and air mixture explodes. Now the engine is ready for its last stroke. To prepare the cylinder for the next intake stroke, the exhaust valve at the top opens. The piston moves up and pushes out the burnt gases. The burnt gases must be pushed out of the cylinder, because if they were not, they would keep the next batch of gasoline and air from burning properly. If you want to see that this would happen, just do this. Fit a wire handle on a jar top and put a candle in the top. Light the candle and lower it to the bottom of a tall glass. Cover the glass with a piece of cardboard. Soon the candle burns up all the oxygen in the glass and goes out. As soon as the candle goes out, slide off the cover and lower a burning match into the glass. Now clear the burnt air from the glass by pulling out the jar top, in the same way that the piston in the automobile engine pushes out burnt gases on the exhaust stroke. Now when you put in a burning match, it stays lit. So we see that each cylinder of a gas engine in an automobile has 4 strokes: intake, compression, power, exhaust. And these 4 strokes are repeated over and over again, many times a minute. The force obtained from the movement of the pistons up and down in the cylinders is used to turn a shaft, which transmits the force to the wheels. And that's what drives an automobile. Now, when the engine of an automobile is running, it gets very hot. So hot that parts of it would melt if it were not cooled. To cool the engine, water is pumped through a jacket that surrounds the cylinders. How does plain water cool a very hot automobile engine? Here's an experiment you can do that will show you how it can. If you take a paper cup and put it over a flame, the cup catches fire. But now, with another paper cup, pour in about 1/4 cup of water. Hold the cup over a candle flame, and the water soon starts to boil. And yet the paper cup does not burn. The reason is that the water, even though it is hot, carries off enough heat from the cup so that the paper does not get hot enough to burn. In an automobile engine, water removes heat from the cylinders in the same way. It carries the heat to the radiator, where it releases it to the air. And now you know a great deal about how automobile engines work.